Hi. In this video, we'll be talking about the final results of our experiment. So this is your original slide that you have sent me, but I have made some changes into this. Here you are showing SSIM, MSE, PSNR, ASR, and on next slide you have shown the mean absolute error. But ASR, that is attack success rate, is not that much relevant. So what I did is I have modified this slide, and this portion I have pushed onto the previous slide, and now we have SSIM, MSE, PSNR and MAE only. So we will be discussing these four parameters. And for your easy understanding, I have added the explanation as well. So you can discuss this while you present the results. The first one is a SSIM. So SSIM is a metric which is used for measuring the similarity between the images. So more the similar images, more the similarity value, that means image reconstruction is better. So here we are comparing the original image and the image reconstructed after applying LCPCN network and the Sargent model. So here similarity value is the highest for our model. We have compared it with four other model as well, including SIE, ARN, GN and ResNet. And as you can see that this is the average SSIM is the highest for our model. That means the reconstruction is better. Similarity value can vary between 0 to 1. 1 is the perfect reconstruction, 0 is the worst reconstruction. Unlike MSE, that is mean squared error, or peak signal to noise ratio, the SSIM considers the structural information, contrast and the luminance to make it more aligned with the human visual perception. So SSIM is very important while we compare the two images. The next is MSE, that is the mean squared error. So mean squared error is basically a difference measure. That is, it measures how different two images are. So difference should be as minimum as possible, whereas the similarity should be as high as possible. And as you can see that the proposed model has average MSE 0.98 only, whereas the other models have 3.18, 3.61, 4.21 and 4.53. The next is a PSNR. PSNR. So PSNR is a peak signal to noise ratio. It is used to measure the quality of the image. So we have not been persistent with only one parameter. Rather, we evaluated the robustness of the model from different angles, like similarity, dissimilarity, quality of the image, etc., so that we can judge the performance of model in all different scenarios. So PSNR is a metric used to measure a quality of the reconstructed or the compressed image compared to the original image. And it is widely used to assess how much distortion or noise has been reduced. So higher the PSNR value, better the quality of the image. And if we go by that, we can see that the proposed model has the highest average PSNR. So in all the cases, we have taken the results on a set of images and we have averaged that particular measure. So this is not for one image, rather it is a set of all the test image. It is an average value for set of all the test image. And lastly, we have a mean absolute error. So mean absolute error is used to measure the average absolute difference between the predicted value and the actual value. So MAE is a difference measure, so it should be as minimum as possible. Fine. So minimum value is the better one, and proposed model is having the smallest possible MAE among all four model. So this shows that how nicely or how accurately the proposed model is reconstructing image compared to the existing one. So our model stands out in case of reconstruction of image or the removal of adversary. Next is a face verification. After we reconstruct the image, we have used MobileNet V1 architecture, which also we have done a lot of modification into that. Just to see that whether model is good or reconstruction is actually good or not. Because see what happens, often it has been observed that when people try to improve the quality of reconstructed image, the performance of model degrades on the original image. That is also possible. So that experiment also we have conducted. But as of now, on this slide, we have discussed various parameters like accuracy, recall, precision, F1 score, etc. and we have compared it with four well-known existing approaches. So accuracy is the measure of how correct or precise something is, and it measures how many true positive and how many true negatives are there. That means positively labeled classes should be labeled positively, and negatively labeled class should be labeled or predicted as a negative. So that what accuracy measures. But however, it is not that great if we talk about the imbalanced data set, right? Like a fraud detection, where 99% transactions are legitimate, and hence the accuracy could be very high, but still it is not that important, right? So we need some other measures as well. So to incorporate that, we have used the recall and precision as well. So recall is a proportion of actual positive cases that were correctly identified by the model, and high recall, that implies we have a lower false negative. That means the actual positive cases are classified as a positive one. Okay, that's what recall. And in the comparison, we can see that our model is having the highest recall, whereas if we talk about the precision, then precision is also important for correct, and it measures the proportion of correctly predicted positive cases out of all cases predicted as positive. Right? So in that way, precision is also highest for our model. Still, when data set is imbalanced, the good measure for assessing or judging the quality of model is a F1 score. It utilizes precision and recall, and it gives us the balanced value. Right? It combines both the value, and it is good when data set is imbalanced. And F1 score is one of the most popular score for assessing the quality of the model. And as you can see that our model is having the highest F1 score of 0.97 compared to rest of all four models. And finally, we have also used Cohen-Kappa measure. So Cohen-Kappa score is a statistical measure used to measure the level of agreement between two raters or the classifiers. So it also counts the chance of probability, and statistically it is more important, and it says that our model is having the highest Cohen-Kappa score among all four. So like reconstruction, our model is good from all the perspective for classification as well. Then we have also compared the scenario that what is the performance of model on the original image. See, it has been often observed in literature that when people try to improve the performance on reconstructed image, that models start misbehaving on original data, and accuracy on original data goes down. So to observe that, we have conducted experiment on all three kind of image. The blue bars represents accuracy on original image, orange bar indicates accuracy on attacked image, and gray bars indicate the performance on the reconstructed image. And that too we have analyzed against all 5 different classification measure, that what is the accuracy, recall, F1 score, precision, and Cohen-Kappa for all 3 kind of image. And we can see that the orange bar is slighter slow, and that's very obvious because it is a noisy image or the attacked image, and there are high chance that model will do misclassification on such images. But once we reconstruct it using our proposed model, we can see that the recognition accuracy is almost as high as the original one. Right? So it is a slight little bit lower, but it is still quite well accepted performance. So our model stands out in that case as well. And these are the experiments for different sample size, where we have used one sample per class, 5 sample per class, 10 sample per class, 15 and 20. And it's very obvious as training size increases, the performance will also go high. So that accuracy, precision, recall, F1 score, and Cohen-Kappa, we can observe that it is going high and high as the sample size increases. So this was all about the discussion on the final results. If any other kind of results are asked by your supervisor or advisor, let me know. Thank you.